In this video, we're going to be multiplying radicals, and do notice that in order for us to multiply these radicals right here, we want to make sure that the roots index must be the same. For instance, notice that this is a cube root and this is a cube root. So even though our radicands are different on the inside, because this is multiplication, that is fine. We do have to make sure just the index are the same. Now, so in this case, what I'm going to do when I multiply these, I'm simply going to multiply this 4 times this 2. And so therefore 4 times 2 gives me 8. So my answer is going to be, I have a cube root of 8. Now, we always want to see, can we evaluate this further, right? Because if this can be evaluated and give us an integer, well, then we need to go ahead and write that answer. So I'm going to go ahead and get my calculator right quick. And I'm going to type it in. I'm going to hit math to go to cube root. And I'm going to type an 8 in there and see, is there some number that can be multiplied to itself 3 times to give me 8? And there is. It says it's equal to 2. So my final answer for this is simply 2. Let's go to number 2. So in example number 2, notice we have a couple different things going on. First of all, we have a number in front of the first radical that's being multiplied to it. So we have 4 times this fourth root of 27. And then we also have a multiplication sign here. And again, we have 2 times a fourth root of 3. So on this one, the way I do it is at first I handle the numbers that are in front of the radicals. Now I'm going to go ahead and multiply those out. The order in which you multiply does not matter. So you can multiply in any order, but I like doing these numbers first. And so therefore I'm going to take the 2 and multiply it to the 4. And that's going to give me 8. Next, since both of these have the same index, there's an index of 4 and an index of 4. I am now going to multiply this radical times this radical, right? And really what we're multiplying is the radicands. Since they have the same index, we can simply do that and combine them. So I'm going to go ahead and do 3 times 27 in my calculator. And notice it gives me 81. So then I end up with a fourth root of 81. Now, I could stop there, but we do want to make sure that this can be evaluated further. And a lot of people will stop. Now, maybe it can't. If I put this in the calculator and it stays a fourth root of 81, well, then I'll leave that as my final answer. But if it can be simplified into a whole number, I want to go ahead and use that number. So let me get my calculator. I'm going to hit math. I'm going to go down to my option 5 where I can put in the index of 4. And I'm going to put 81 to see, is there a number that can multiply to itself 4 times to give me 81? And there is. It's going to be 3. So I'm going to go ahead and change this now. So this actually becomes 8 times our value from there, which was 3. Now if I multiply that out, that's going to give me 24. And 24 is my final answer. I just want to prepare you, you may not always have a final answer that's a whole number, right? So just keep that in mind. There may be what we call a surd, which means there may be a radical that cannot be further simplified. And if that were the case, you just write it simply after the value. In other words, kind of how this one is written, 2 fourth root of 3, right? So 3 was a surd. It couldn't be further simplified. But in this case, it could be. You can always check these with the calculator as well. I know I didn't check the first one, but I do want to show you if I were to take this and put it into the calculator. For instance, I'm going to go ahead and put in 4, and then I'm going to hit math and put my index of 4. So 4, index of 4, and then I'll put 27, and then I'm going to simply multiply this too. And I'm going to go ahead and put in my next one. So let me actually put the radical symbol first. Alright, and then we have 2 with it, and then we have an index of 4. And then we have 3 for our radicand. So notice that's exactly what we got on the paper. If I hit enter, it gives me 24, which is the same thing I got here, verifying that I did the multiplication correctly. Now on to number 3. Now number 3 is going to be a little bit more complicated. I do want you to notice that we have the square root of 5 being added to the square root of 11, and then we have it in parentheses and it's being squared. So what we want to do at this point is we want to go ahead and write this out as the product of two binomials being multiplied. And what I mean by that is I'm going to simply write it as the square root of 5 plus the square root of 11 times the square root of 5 plus the square root of 11. And that gets rid of this power of 2 that we have here, right? Because now we are simply multiplying this binomial, because it's made up of two terms, together. So what we're going to do from here is we're going to go ahead and we have to FOIL it the same way we would do if we were dealing with quadratics. So we're going to take our first term, in this case happens to be square root of 5, and I'm going to multiply it to this square root of 5. So I'm going to write out the process so you can see everything that I'm doing. So for the f in FOIL, first times the first. And if I multiply square root of 5 times square root of 5, it just simply is going to give me 5. So that just turned into a whole number. Now I'm going to take this square root of 5 and multiply it to the next term. We call that our O, our outer. The first is multiplied to the outer. So I have square root of 5 times square root of 11, and that is going to give me the square root of 55. Notice all I did in that case was multiply the radicand of 5 to the radicand of 11. And now we're going to go ahead and do the I in FOIL, which is to do the inners. So I'm going to take this inner square root of 11 and multiply it to the square root of 5. Once again, 5 times 11 gives me 55, so I end up with the square root of 55. Now I should be writing my signs here. These are all positive, so I'm just going to put a plus sign in between them. And now I'm going to go ahead and I'm going to multiply the square root of 11 to the square root of 11. So that's our L. So square root of 11 times square root of 11. And anytime you multiply a radical to itself, it's just, and that has an index of 2 like these, it's just going to become the radicand. So it's a positive 11. Now we're almost done, but we got to put some terms together. So first of all, I'm going to put these two terms in the middle together. And notice that we have two of them. Notice there is an invisible 1 in front of each one of these. And so if I have a square root of 55, a 1 in front, 1 plus 1 gives me 2. So I have 2 square root of 55. And then we have an 11, and we have a positive 5 that we have to put together. So I'm simply going to take this over here and put it together with the 5, and 5 plus 11 is going to give me 16. And this 2 square root of 55 is positive. So for my final answer, just to make it look nicer and cleaned up, I simply have 16 plus 2 square root of 55 for my final answer. Once again, I'm going to put this in the calculator, and we're just going to compare and make sure that I did the work right. So if you wanted to do that, if you wanted to try it, we just get our calculator. I'm going to put a set of parentheses. I'm going to go ahead and put the square root of 5 plus the square root of 11, close parentheses, and square it and hit enter. And it gives me 30.832. And now I'm going to take my final answer and do the same. So I have 16 plus 2 times square root of 55. Let me erase that. I didn't have to put the parenthesis. And I'm going to hit enter. And notice it gives me the same value. So that way it confirms that I did the work right, and this answer is valid.